Good evening, everyone. Uh, we'll start in 2 minutes. Let other people also come. Meanwhile, please tell me what are the topics which are taught in this week? Anyone? Hello? Can anyone hear me? Hello? Please write in the chat box what you have been taught in this week. Did they taught you any of these topics? I'm writing. Okay. So we will take problems based on that. The week is about the interpolation problems, right? So we have seen Newton's forward backward interpolation earlier. So we will try to cover some of these topics which I'm writing. Newton's divided difference, Lagrangian interpolation, then Gauss forward central difference interpolation, Gauss backward central difference interpolation, and Stirling central difference interpolation, Basel's central difference interpolation. Can anyone tell me out of these topics what have been taught in this week? Out of these topics, what have been taught to you in this week? Anyone? I because these are large number of topics, it cannot be covered in an hour. We have to take it in two sessions. Okay. So please tell me what are the topics which has been taught in this week out of these six. Anyone? Okay. Lagrangian interpolation, then Basel central difference. Okay. Then Lagrangian and Basel central difference. And what else they have taught? Stirling. Stirling also they have taught. Okay. Then did they taught Newton's divided difference? Newton's divided difference. What about that? It is not taught. Did they taught goes forward and goes backward? Anyone? Because this is the sequence I was going to take to solve your problems. So if you tell me, we can start as early as possible. Please respond. Satya Sasi, are you there? Subhashri, Diya Darshani, okay. Is Suvetha, any more topics they have taught other than Lagrangian, Bessel and Stirling? Suvetha, Gomati, had they taught any topic other than this? Stirling, Bessel and Lagrangian interpolation. Gomati, are you guys able to hear me? Hello, are you guys able to hear me?
Yes, sir.
Yes, so please tell me, other than this, is anything taught to you? Whatever I have written, whatever I have written, the is unticked topics has done in the class. Suvetha, yes, yes, tell me. Please unmute the mic and tell me.
Sir, I didn't attend the class, sir, so I don't know.
Oh, okay. Uh, Anyone else? Okay. See, these topics cannot be covered without explaining this because these two central difference formula came from this goes forward and goes backwards. Okay, must have taught this. Newton divided difference is just a extension of your Newton's forward and backward. Okay, so let's start with the Lagrangian interpolation. Okay, so uh, we use Lagrangian interpolation? We have Newton's forward backward interpolation. Then why we use Lagrangian interpolation? What was the need? Anyone knows this? Does anyone have any idea why Lagrangian interpolation is there if we have Newton's interpolation? We Why we use interpolation? We have range of x values from say x1 to xn, okay, and then we have corresponding y values for y1 to yn, right? So if you want value of y, a particular x which is in between this, okay, so we use interpolation, right? Earlier, the new interpolation which we have used, it was for the what was the earlier interpolation? It was Newton forward interpolation, Newton backward interpolation, right? But the important thing is the interpolation was applicable only for those whose x values are at equal intervals. Whose x values are at equal intervals. So what we will do if we have x values at unequal intervals? For those in those case we are going to use all this interpolation. Okay. So first is your Lagrangian interpolation. Okay. So like in Lagrangian interpolation, I will explain this with help of example. So let's solve one. Okay, do you know how to find out these coefficients of the Lagrangian interpolation? Did they taught you? They have taught you, right?
Yes, sir.
Okay, so we'll jump on the problem, and while solving we will have better idea how it is used. Okay, so first we have x values, 5, 7, 11, 13, 17. You can see these are unequal interval values, right? Which difference of 2, 4, then again 2, 4. Okay, f of x. The corresponding values are 50, 392, 1452, 2366, and 5202. Question is, you have to find the value of function f of x, find f of x at x is equal to 9. That is f of, okay. So we will solve this by Lagrangian interpolation. Just carefully listen to first step, which I'm how we are going to tackle this. Okay, so we are we have values 5, 7, 11, 13, 17. Then we have to find at 9. So 9 is in between this 7 and 11, right? So value will lie in between 392, 1452. It is like we are guessing, right? Okay, so when we calculate by Lagrangian interpolation, what we do, we calculate at coefficient for each x values and multiply the functional value with that respective coefficient. Okay, and sum of all this gives the answer. Okay, so just see the method. So our formula Lagrangian, you can say, we write Lagrangian interpolation formula. I'm just for your rough idea, I'm giving this. If we want functional value at any x, so what we do, sum of all minus that corresponding this value, corresponding xi value, this respect to this is the coefficient. Okay, okay, this is the coefficient, and okay, and with respect to that we will use other values, okay, the difference of those other values. This will be clear as we will write the problem, okay, as we will solve, okay. You can just simply represent it in this way, okay, where I is your, like, say this is, you put I 1 2 3 4 5, so this is first value, and j will never be equal to I, okay. So we have to take sum of this and that respective functional value, okay. So just see, so we are supposed to find f of 9, right? So first first our coefficient is first coefficient for x is equal to 5. How we will calculate? We just simply take this 5, okay, and other than 5 we will write all the terms in, we will subtract all other values from 9, okay, like this. Just see the method. So our value is 9, 9 minus 7, okay, 9 minus 11, 9 minus 13, 9 minus 17 upon, now instead of 9 we will take at whatever value we are taking the interpolation, 5 minus 7, 5 minus 11, 5 minus 13, 5 minus 7. Is this clear? Do you understand what we did?
Yes, sir.
What we did, we have to find out value at 9, okay, and with respect to x is equal to 5 first, okay. So we, in numerator we subtracted all other values other than 5, okay, and in denominator we just find out the distance of the other points with respect to 5, like 5 minus 7, 5 minus 11, 5 minus 13, 5 minus 17, okay, into at what value we have calculated coefficient at 5, so we will take functional value of that. So which is, what is the function value of 5?
150.
150, okay. This is 1, this we call we got first term. Likewise we will get four more terms because we have 5 x values, so we will get coefficient for respective x values, okay. So we will get 5 terms and we will add up and we will get the answer, okay. So similarly for 7, what we will do, 7, and we will sorry, 9, and all other terms other than 7 we will subtract, right, and we will find the distance from 7, right, into what value we are calculating a coefficient for, what, x is equal to,
392.
so 390,
7.
okay. Is it clear now? These are the coefficient, sorry, these are coefficient of Lagrangian term, and this is the respective functional value. It is like, see, if we have one segment, okay, we have one segment, okay, we break it into, say, 1 by 3 and 2 by 3. What is this 1 by 3, 2 by 3? 1 by 3, 2 by 3 is the weightage, okay. So these coefficients are nothing but the weightage, how much weightage should be given. If we are supposed to calculate the value at this point, so say which is at, say, 3 by 4, okay, so we will give the weightage with respect to these points, If it is near to it, so there will be more weightage. If it is away from it, then the weightage will be less. Okay, so it will be ensured by this coefficient. Okay, is it clear whatever I am saying? Are you getting the idea of this coefficient? Anyone? Is any difficulty in understanding? What I am telling is the coefficients are calculated based on the distance which are below it. Okay, and the distance of other points with respect to point at which we have to find out functional value. Okay, so we are giving the weightage with respect to how far the point is from the other points, like how far the point at which we have to find the value is from the other points. Okay, so we will find out third term. Is it clear? Are you understanding the meaning
Yes,
of
sir.
this coefficient?
Yes, sir.
Okay. So, uh, can you tell me the third term? The third term will be 9
9
minus,
minus 5.
yes, right, 9 minus 5, 9
9
minus
minus 7.
7, okay. 9 minus 7, 9 minus 13, and 9
9
minus,
minus 13.
and 9 minus
And
17.
9 minus 17.
Then we are calculating distance from where? 11, right? So just simply 11 minus 5 minus 7,
11.
right? And this is the functional value of 11. Likewise, fourth term. Fourth term is what? 13. With respect to 13. 13 minus, sorry, respect to 13. So all the other terms than 13, right? And distance from the 13. Correct? Value is 2366. Correct? Last term. We have 5 term. So this is last term. 17. Correct? The functional value is, take your time and give me the answer. This will give you the functional value at x is equal to 9. Okay.
Yes, sir.
Oh. Calculate and tell me. Please, if you find any difficulty, okay, if you find any difficulty, let me know. It's very methodical. Calculations are slightly time consuming because of the coefficient calculation. So, but only it is in calculation there are more efforts, but understanding wise it is very easy. Okay. So, calculate the value of function at x is equal to 9. First, you calculate first term. What is the first term calculation? What did you got? You can tell me in the fraction. Okay. You can tell me in the fraction. You have any uh, this value? Let, give me time. I'm bringing my calculator. Okay. Hmm. What is the first term? What is the first term we got? Yes, Suvetha, first term.
Minus 128 divided by 1152 into 150.
Minus 128 divided by 1 minus 128 divided by 810 into minus 128 divided by 810 into 150. Okay, okay. This you just tell me the coefficient value. There is some mistake, I guess. Coefficient value. What is the coefficient value? Komathi. What is the coefficient value? First term coefficient value. What is the coefficient value of first term? Sastika. Anyone? What is the coefficient value of the first term? It's very easy. It's not very time consuming thing. Gomathi. 810. It is 810 Komathi P. What is 810? You are writing. Okay, 810 is final answer you have calculated or what? Suvetha? Final answer. Okay, the final answer is correct. Okay. What is the first term did you got? Okay, minus 1 by minus 128.
23.703.
23 point first term. No, first term Komathi is right. 16.66 minus 16.66. So it is minus 50 by 3. Okay. Second term, please, whoever has answered this 23 something, please recheck. Then second term, what is the value of second term? The whole. Okay, 209.067, correct. Third term, 1290.6, correct, correct. Can you tell me in the fractions? For fifth term. No, this third, second. This is fourth term here, whatever I have written. This is fourth term. What is the fifth term? People have got the answer. That means, is this matching? Correct, correct, correct. So 8100 is the answer. Okay. Is it clear? Is it clear?
Yes, sir.
Okay. Move on to the next. Just this we use because the intervals are unequal. Okay. So we can use Lagrange interpolation. Even if intervals are equal, we can still use Lagrange interpolation, but it is very tedious, so we use simpler methods. But if we have unequal intervals, then we cannot use those previous methods which we have learned. Okay, so this is Lagrange interpolation. So let's take another example. We will find out polynomial. We know if we have 4 points, we will get polynomial of what order? What will be the polynomial of order? Hello, anyone? What will be the order of the polynomial or degree of this polynomial if we have 4 data points? We have 4 data points. So what will be the highest power of the polynomial which we will get? Suvetha, what will be the highest order of the polynomial which we can fit if we have 4 data points? Gomathi, are you understanding my question? We have 4 data points, then what will be the highest order of the polynomial that can be, or highest power term of the polynomial?
3, sir.
3, right? Means that will be cubic polynomial, right? Okay, so similarly, now what at what point we will calculate? What will be the x?
5.
No, x will be the x because we are calculating polynomial, right? It can be any x, right? When we are finding polynomial, we are trying to fit that polynomial for any x value. So the x at which we are going to find out will be x itself, right? Right. So what will be the solution? We have to find that x. So what will be the first term? Same procedure. What will be the first term? We will calculate first term with respect to 0, right? So what will be the coefficient? How we will calculate the coefficient? Komathi. We will do the same thing, right? We need at x. So with respect to this point 0, so we'll subtract x from other points, right? So x minus 1, x minus 2, x minus 5, right?
Yes, sir.
Right? Divided by what?
0 minus
Yes,
2.
0 minus 1, 0 minus 2, 0 minus 5 into,
2.
right. So calculate other points. So with respect to 1, we will get this. second term with respect to 2 we'll get this respect to 5. Right? 5 0 2 5 0 1 5. Okay. Okay. Calculate. What is the first term? Will be the first term. So we have x minus 1 into x square minus 2x minus 5x minus 7x divided by what? So 2 2 minus 1 minus 1 minus 1 1 minus 5. Correct? Right? Are you getting this? This is our first term. Then second term on correct. Third term on L2C. So upon minus 3. So upon minus 3 minus so 2 into okay. Right?
Yes, sir.
Okay. Then simply find out f of x. You have to just expand. We understood the method of finding polynomial. Who can find polynomial which can be fitted in any kind of interpolation? Okay, when you find out the polynomial, you have to find the interpolation value at x itself, because we are going to fit the polynomial which can satisfy any x values within the given limit. Okay, so what will be the polynomial? Has anyone tried this? Okay, this is uh, I'm giving you directly the polynomial. Okay, you can try it. Okay, so x cube plus x square minus x plus 2 is the polynomial you should get. Okay, okay,
Yes, sir.
okay. So is this clear how to find out polynomial? Okay,
It is clear, sir.
we can for any interpolation we can use this. Okay, if you want to find a polynomial which can be fitted in particular interpolation, we will use the same steps. Okay, only this formula will change. Like in Lagrangian, we calculate coefficient and functional value. In Newton's backward, we will write it in del square del that in different terms, right? Okay, okay. We have done with this Lagrangian thing. So we will move on to Newton's divided difference. Okay, this Newton's divided difference is similar to your Newton's forward method. On the difference in there is slight difference in of that Newton forward difference method and divided difference. Okay, which we will see when solving. Okay, Newton's divided difference. Okay, this method can also be used for unequal intervals. Okay, unequal intervals means what? Unequal intervals of what? Unequal intervals of what? Ravi Shankar?
X.
Yes, right, x. Mm, these methods can be used for unequal intervals of x. Okay, earlier was can use only for the equal, right? So let's see the problem for Newton's divided difference. Okay, now we will how what is the difference? Very small difference. Okay, between Newton's forward difference formula and Newton's divided difference. Okay, so let's find out. We will solve one question. Question is we have x values 5, 7, 11, 13, and 17, and their respective functional values 150, 392, 1452, 2366, and 520. Okay, our question is to find value at f of 9. Okay, at f of sorry, I will write here actually. Just note down the question. Okay, 3, 392, 552, 2366, 5203. Okay, this is 11 method. Find f of 9, that is functional value at f of 9 Newtons using Newtons divided difference. Okay, so it is similar to our Newton's forward difference. Okay, so what we do, we first find out the difference table, right? We'll write x values are 5, 7, 11, 13, 17, right? Is right respect to f of x values 150, 92, 452, 366, and 520. Then what we do? We do uh, delta f of x, right? What is delta f of x?
377.
377. How did you calculate? 392 minus 150, right?
Yes, sir.
What? 392 minus 150 is what?
Sorry, sir.
Okay, no issues.
242, sir.
240. Okay. We will calculate similarly this difference. Okay. Now, what will be the different thing in divided differences? We will divide this difference with the difference of the respective x values. Okay. So 7 minus 5. Okay. So what will be the value of delta f of x?
1 to 1.
1 to 1. Okay. Okay. Did you understand this? This is the only difference. Okay. Similarly, calculate for these two values. It will be
1060.
10.
60.
Is it correct? Are you following the steps? You have just found out the difference. But in divided difference, we will not only find out the difference. We will find out the
265, sir.
difference. Yes. 2,
265.
265. Yes, correct. So we will find out difference. We will divide it with the respective difference in x values. Okay, difference of the respective x values. Okay, correct. Then this, what is this difference? Divided difference value. What will be the divided difference value?
457, sir.
457. Correct. For this, for this, yes. What is the value for this? 709. Correct. Again, we have got this del square now. How will you find out del square? How will you find out del square? Anyone?
24.
Why 24? Why 24? It is correct. Why 24? because
11 minus.
yes, correct. 11 minus 5 because now interval become this, no? Earlier it was this. So we do. Now these values are till this, right? Till this. So interval will be this. So what we will divide 5 minus 11, right? Is everyone getting this?
Yes, sir.
Okay. So what will be again? Yes. What will be this value? 24. This value. These are very simple things, but uh, you do any silly mistakes, then it will end up with a very wrong, extremely wrong answer. Okay, someone has 32, right? 32 and last value. What is 48? 48 is not the answer. 32 is the correct. Then 7095457 upon 17 minus 11.
42, sir.
42. Correct. Similarly, calculate del cube. Del cube. We'll simply write del cube directly.
1.
1. Then
Again 1, sir.
again 1. Right. Correct. Okay. Again, we will do further. Is it needed?
No, sir, not needed. 0.
Yes. Correct. Now, same. What we will do now? Is this clear? This table is clear, right? Now for f of 9, okay, we will take forward. In forward, what values we take? How we take the values in forward? The upper branch, right? So we take these, this, and this, right? Right? Hello, anyone? Are you following?
Yes, sir, following.
Why we take upper branch? We do it right in forward difference. We do these things, right? It is similar to it. Only difference is we have divided with the interval. The difference of the interval, right? So calculating this 150 plus now the second we take first f of x value, then del f of x. Del f of x is with respect to phi, right? So we'll subtract the value at which we have to find out into the value at del f of x. Then we are going till 7. Okay, we are going till 7, so we will subtract both 5 and 7 multiplied by 24. Is it clear? And
Yes,
then
sir.
finally, is it clear? Is this step clear? See, first, this is the first step. We are gone from 5. Okay, so we'll subtract 5 and multiply with the function value. Then we go from 5 to 7 here, then 7 to 11. Okay,
Yes, sir.
right? We can consider this value as like at 5, this value as like 7. Okay, the upper one is at 11, this is at 13, likewise. Okay, similarly 5 and 7, what will be the upper one? This 5, likewise. Okay, so this will be helpful in further process, not now. Is this clear? We just subsequently the subtracting the value from the point at which we have to find the function. So what is the answer? Anyone? We have calculated this earlier. Do you know this?
810.
We have calculated this earlier. This is the same problem, right? 5, 7, 11, 13, 17, right? So values will be same. So did you calculated this or you just copied? 810, correct. Okay, correct. Understood this method, Newton's divided difference?
Yes, sir. We understood.
Okay, okay. Then, uh, uh, I will give you brief about this Stirling central difference and Bessel central difference. Okay, and Gauss forward. Okay, before that we have to go to Gauss forward, right? So these methods are clear, right? Lagrangian and Newton's divided. You can also take one problem based on polynomial, fitting of the polynomial in divided difference. Okay, let's take that one. Should we move on next interpolation method, or should we practice one more problem of this? Or you understood this and move on to next method? Suggest me.
So we can go to the next topic, sir.
Can go to next topic. Is this understood by everyone? Right? Gomathi, Priyadarshani, Ravi Shankar. Is this clear? Just tell me yes in the chat box. Yes. Okay. Okay. So, okay, they have not taught you the Gauss forward and Gauss backward, but they have taught you the Stirling method. 6. Do okay, just first brief. Yeah, this Gauss forward central difference interpolation is has been taught, right? Or just a derivation? People who have attended the class, please respond. Ravi Shankar, have you attended the class? Okay. Priya Darshani, Sastika, anyone? Komathi, had you attended the class? Okay, let's take the problem based on if these methods are not taught. I have to take problem on Stirling. Okay, so let's take problem on Stirling method. Okay, is it? Do you know? Oh, the Stirling formula for the Stirling central difference interpolation. Can anyone tell me formula for the Stirling interpolation? What is Stirling interpolation? It is a kind of central difference interpolation. We have earlier seen forward interpolation, backward interpolation, right? This is the kind of central difference interpolation. So, central difference interpolation where we will use? We have used Newton's forward interpolation when we have to find the functional value at point which are near to the starting point or which are near to the values which are at the top of the table. Okay, we have used backward interpolation when we have to find the values, functional values at the point which are at the bottom of the table, or we can say at the end of the interval. Okay, so if points are at near to the center, we will use center difference interpolation, right? So one of these central difference interpolation is Stirling method. Okay, so we will take one problem on Stirling interpolation. Okay, can anyone tell me the formula for the Stirling interpolation? Can anyone tell me the formula for the Stirling interpolation? Yes, anyone? No one attends the class, I guess.
yp equal to
What?
y naught
Yes, yes, Kumati.
yp equal to
Okay, yp is equal to
y naught plus
Why not plus
y
p
naught plus
P into del
into
Y naught
p into del y naught
plus
plus,
P square divided by 2 factorial del square of Y naught.
is this correct formula? Okay, let's discuss this. This is the numerical. We have to find out. We have given this data set. We have given this data set. Okay, and we have to find out value at 12.2. It is almost near to the center, right? Okay, here the formula for the Stirling. Okay, so wait, just completing this. Okay, okay. Stirling CD interpolation formula has come from where? It is average value of what we get from Gauss forward CD and Gauss backward CD, right? Is it right? CD interpolation we get from by averaging the values of Gauss forward CD and Gauss backward CD. Okay, So when we average these two formulas, we get formula for the Stirling CD interpolation. Okay. So formula here also we will calculate the difference table like we calculated in Newton's forward, Newton's backward. We will also calculate the difference table, but the difference table is slightly different. Okay. So formula here. Okay. Before the formula, where we should know where it can be used. Okay. We have calculated the p value earlier, right? What is the p value when we calculate for the Newton's forward? What is the p value when we calculate for the Newton's forward?
X minus x naught divided by h.
Right. For backward,
X minus xn divided by h.
right. Here also we will calculate p value, but p value will be based on the some center value. We will consider values near to the center. So here are five values. So take this 12 is at the center, right? We will take 12 as a center value, which we will say x naught. Okay, okay, and we will calculate the p value like x minus x naught upon the interval. What is the interval?
1.
1. So 12.2 minus 12. Our x is 12.2, right? Upon
Yes, sir.
1. What will be the value of p?
0.2.
0.2. Okay. So in CD interpolation, we have two methods. One is Stirling CD interpolation, other is Bessel CD interpolation. Okay. So how we choose which method to be used? Okay, choose this based on value of p. If value of p is in between minus 0.25 to plus 0.25, if value of p is between minus 0.25 to plus 0.25, right, then we use Stirling CD interpolation. Okay, is it clear?
Yes, sir.
When we use Stirling, when value of p is in between this, and Bessel, we use this Bessel thing when we use Bessel interpolation. Do you have any idea? Anyone? When do you use Bessel? You have been taught Bessel formula, right? Bessel CD interpolation formula has been taught, right? Like you have, some of you have told me. Suvetha has told me, right? Suvetha, tell me what is the condition when we use Bessel interpolation? Yes, Kumati, yes. Do you know this? You have been taught this, right? When value of p is in between minus 2.5, well, sorry, minus 0.25 to plus 0.25, we use Stirling CD interpolation. Okay. So Bessel CD interpolation, when we use this,
0.5.
when value of p
Zero point 0.5.
is it correct?
I think so, sir.
Okay, this is not correct. Okay, we use this when value of p is in between 0.25 to 0.75. Okay, is it clear? Is it clear now?
Yes, sir.
Okay, So in our problem, this is very important. Okay, you just make a note of this. When we should know when the formula should be used. Like when we use Lagrangian interpolation, we can use these two these things when we have unequal intervals. Okay, if we have problem with unequal intervals, okay, we have to solve. Then uh, we have unequal intervals. We have to use these methods. We cannot use other method. Also, this can be used for equal also, but methods which are being used for equal intervals cannot be used for unequal interval problems. Okay. Similarly, we can use Stirling and this Basel based on the value of p. We got value of p zero point 0.2. So, can we use Stirling interpolation here? Can we use Stirling CD interpolation in this problem? We got p value zero point 0.2, right? So, can we use Stirling interpolation here? Are you getting my question? Can we use Stirling interpolation formula here? Anyone? Kumati, Suvetha, Ravi, Gomathi? Are you getting what I am telling? Are you understanding?
Sir, your P is 0.2, but P should be greater than equal to 0.25, so we can't.
0 0.2 is greater than 0.25.
Sir, the value of P is 0.2,
Huh?
right?
Yes.
So to use Bessel CD interpolation, our P should be greater than equal to 0.25, no?
Yeah. So,
So we can't use.
but yes, but my question was, can we use Stirling interpolation?
Yes, we can use.
Right? Yes. Means you
Hmm.
got the point. Right? Okay. We can use this because value is lying in between minus 0.25 to 0.25. Okay. Our value of P is lying. Okay. You have to check these things. Okay. Before you solve the problem. Okay. So simply we will again make the table now in central difference interpolation. How we will make the table? We will make the table based on the value of P. Okay. So for 10, for 10, value of P will be, how we will calculate value of P for 10? 10 minus 12 by, we have to calculate value of P in respect to f of x. Okay. So what is the value of P for 10? It is very easy. 10 minus 12 by 1, right? You just substitute 10 in x here, right? Right? People, are you there? Okay. So it will be, what will be the value? Minus 2. Then for 11, minus 1. For 12, 0. Then 1 and then 2. Right? The respective value is, what are the respective values? There is slight mistake. Okay. These are, okay, the values of f of x are correct. Okay, only these values are not complete values, these are 0 point values, like in this I just correct these values. 0.23. I will first write here. Okay. Okay, these are just functional values which are given. Okay. Okay. Again, here a difference table. Okay, this is value for y minus 2, right? Which is clear, right? We are writing here. This is value for y minus 2, y minus 1, 0, y1, y2. Okay, del x, del f of x. Calculate del f of x. Now this is our normal. This is not divided difference. Okay, normal difference. So what is the normal difference? What is the difference in these values? Yes, 0.04093. Okay,
93.
right. Next difference. Next difference. Yes. Next difference 0.03728. Okay. Did everyone got this?
Yes, sir, got it.
Okay. 3421 and 3159. Okay. Now just carefully listen to this. Okay. This is for y minus. Okay. This is sorry. This is for y minus 2. This is for y minus 1. This is for y0. This is for y1. This is for y2. Okay. So this value, this value. Okay. So this value will be for y minus 2 because we have calculated in backward. Sorry, we have calculated in forward. So we will take first value. So this is for del y minus 2. Similarly, this is for del. So value below it for what? This value will be for what? Anyone please tell me first. Yes, Ravi, Komati. This value is del
Del why not?
del y naught and this del y1, right? Again, we will calculate del x square, right? So del x square. Okay, what will be the values? I'm just giving you the values because time is running out. So this, these are the values. Okay, the method is clear, right? Okay, correct. So these are del square values. For what? This is very important. This del square value is for what?
Y minus 1.
Y minus 2. Yeah. Right? Are you getting?
Yes, sir.
So below value is for value below it for
Y minus
value below it
1.
for
0.
Okay. Similarly, del cube, yes. I'm giving you the values. Okay, this is value for what? This is value for what? This value is for first value,
Del cube y minus 4.
and below it
Del cube y minus 1.
del cube y minus 1. Okay, final value will be for final value will be
Del
for
power 4 y minus 2.
del power 4 y minus 2. Correct. Okay, this was the most important part. Okay, now formula. Formula is yp. Just see yp is equal to y0 plus. Okay, 0 plus. We will take the average by 2. Okay, into p. Again, next term del y. Next term we will have del square y minus 1 p square by 2 factorial. Okay, these are the standard formulas. Okay, you can remember till 4 terms. Okay, no much need to calculate all the coefficient beyond 4, because these are calculated by taking average of two formulas. Okay, so if you calculate these things at the time of exam or at the time of what your certification exam will be there. Okay, so it will be very time consuming for you. Okay, so you just simply remember this. Okay, okay, the odd terms have average values. Okay, the odd terms have average values, right? And the even terms are just as it is, and we got values in descending like 0. This is even, say this is 0th term. This is 0th term, you have 0. Then first term, you have 1. Then second term, you have 2. Means 0th term, second term, fourth term. Okay, so even terms, okay, you have 0, 1, 2. Okay, then odd terms, you have average values. On odd terms, you have average values. So 0 and 1, 1 and 2. Similarly, if you go beyond 4, you will get 2 and 3. Okay, is it clear? Is it clear?
Yes, sir.
The Sterling formula, okay, just make a note of it, and you can calculate now the value at 12.2, right? That is at p is equal to zero point 0.2, right? Calculating value at p is equal to zero point 0.2, that is value of f of 12.2, correct? So what is the y0? Y0 value is, what is the value of y0? Y0, it is very clear, no? What is the value of y0?
3178, 0.3178.
Right, 0.31788 plus next term del y minus 1 del y0 by 2. Okay, so what is del y minus 1? What is del y minus 1?
0.03728.
And del y0? right? And del y0 by 2, right? Into p, correct? Second term is done. Next, third term, del square y minus 1 minus 0.00307, right? Into p square by 2 factorial, correct? Are you getting these things? Fourth term, point 0.2 point 2 square minus 1 by 3 factorial, because here you have p square minus 1 by 3 factorial. Okay. Del cube y minus 2 del cube y minus 1, what are these terms? Del cube y minus 2 del cube y minus 1, what are these terms?
Minus 0.00365.
Del cube
0.00258.
0.00,
258.
no, it is 0058, 00058. Okay, is it not visible?
Yes.
Okay,
Okay, sir.
0058. Okay, and del cube y minus 1.
Minus 0.0004.
Okay, okay, good. Right? Okay, plus last term p raised to 4 by 4 factorial del raised to 4 y minus 2, our last term. Okay, you just calculate this, okay, and tell me in the next session. Okay, is it clear?
Yes, sir.
Okay, now we will do the remaining methods in next session. Okay, you just calculate the value and tell me the answer for this y is equal to zero point 0.2, that is what we are calculating. Y is equal to zero point 0.2 means what we are calculating? Anyone? Y is equal to zero point 0.2, that
Sir,
means,
Sterling CD interpretation we are calculating.
yeah, no, that is the method, but we are calculating y is equal to zero point 0.2, that means what we are calculating? We are calculating functional value for x is equal to 12.2, right? Right? Ravi, is it clear? Okay. Okay. Is it clear when to use the Stirling and Bessel? Yes, Komathi, is it clear? Gomathi, Komathi. Okay.
Yes, sir.
Okay. Okay. You just calculate this thing. Okay. Do you have any doubt in from the previous session? Any doubt from the present session?
No, sir.
Okay. If you find any difficulty in any of these topics, please you can ask me. Okay, in the while this the at the end of the session. Okay, so Okay. Okay. Thank you. Have a nice day.